Hello viewers, Kinematics question 6. A runner starts at rest, accelerates at 0.6 meters per second squared for 11 seconds, then runs at constant speed for 11 seconds and decelerates at 0.3 meters per second squared for 22 seconds. So the whole process here takes 11 plus 11 plus 22, which is 44 seconds. And first thing we need to determine is the speed at the end of the process. But in order to get that, we need the speed at 11 seconds, which will be the speed at which the runner is travelling during the constant speed part of the process. Okay, so at 11 seconds we need to find what the speed is. So we've got starts at rest, so the initial velocity is 0, so u equals 0. We have in the first 11 seconds, so the time is 11 seconds, and we have an acceleration of 0.6, and we need to find the final speed, so v equals u plus at. U is 0, a is 0.6 multiplied by 11, giving 6.6 meters per second. So that will be the speed during the constant speed part of the process. Now we need to work out what the speed at the end, so at the 44 second mark is. So we're looking at the deceleration part of the process. So here u will be the initial speed, which is the speed at which the deceleration begins, which will be the constant speed of 6.6 meters per second. The time taken to decelerate is 22 seconds, and that deceleration is 0.3. It's slowing down, so that must be a negative. Again, we're finding the final speed. V equals u plus at. U is 6.6. Plus a is negative 0.3 times 22, giving us a final speed at the end of 0 meters per second. So at 44 seconds the runner comes to rest. Now part B is to draw a distance versus time, draw a speed versus time diagram of the situation. Okay, so we're measuring time in seconds for this question, so time is in seconds. The key times are 11, 22, so 11 seconds is when the acceleration stops, 22 seconds is when constant speed stops and the transition into deceleration occurs, and 44 seconds is the time of the whole process. So on this axis we're going to have speed in meters per second. Okay, so the key value of speed is we've found already to be 6.6 meters per second. So at 11 seconds, they are going to be going at 6.6 meters per second. They're going to continue at 6.6 meters per second between 11 seconds and 22 seconds. And at 44 seconds, they are going to come to rest. So that's what our speed versus time diagram looks like. From part C, how can you tell the acceleration from the speed versus time diagram? So the acceleration is the gradient or the slope of the speed versus time diagram. And part D, how can you find the distance travelled from a speed versus time diagram? So the distance is the area under the curve, which we will find in part E. So distance is area under the curve. So that's under the speed versus time diagram. And part E, we need to use your answer to D to find the distance travelled. So we're actually going to do it here. We're actually going to find that distance. So the shape here we can divide up into three shapes. We've got a triangle at the beginning, we've got a rectangle in the middle, and then a triangle at the end. So let's call this acceleration phase part 1, constant speed phase to be part 2, and the deceleration phase to be part 3. So for part 1, we're looking for the area of the triangle. The area of a triangle is half base times height, so this is going to be half base times height, which is half. The base here is 11 and the height is 6.6, and if we calculate that we get 36.3, and that will be in metres. Part 2, we're dealing with a rectangle, so this is just going to be the base times the height, which is 11 times 6.6, giving you a value of 72.6. That will be in metres. And part 3, it's a triangle, so we're finding the area of a triangle, which is half base times height, which is 1/2 times 22 is the base, multiplied by the height is 6.6, again giving you 72.6 metres. Now we need to find the total distance, so if we add those three up, 36.3 plus 72.6 plus 72.6, we get an answer of 181.5 metres. So 36.3 plus 72.6 plus 72.6 gives us 181.5 metres, which is the total distance that the runner travels throughout that 44 seconds. Thanks for watching. Over and out.